Well, good morning, good evening, good afternoon, wherever you join us from around the world. Welcome back to Creation Conversations, where I'm hoping that you can all hear us and everything is all good. It's good to see you all, and it's good to have a few people in the chat already. Tonight's topic, we do have pretty much the whole team here tonight, which is wonderful. We've got John, Glenn, Diane, Craig, and Sam, as well as myself. So it's good to have everybody back again. But today's topic that we're dealing with is actually a topic that has been requested to us. It was actually requested to the team through Craig, and so we've been sort of planning this for a few weeks now. The overarching topic is amber. Specifically, the question was sort of directed about amber and the records that amber show with the not only the bugs and the things that are found inside of it, and you've got Jurassic Park and all that as well, but also in reference to things like climate change, which is seen in the records of air and atmospheric records that are in amber as well. So we're going to deal with all of this. We're going to talk about amber as our general topic. We're going to delve into some of the science behind it, how it forms. We've got several fact file programs as well, which Diane will be bringing us later. And of course, a little later, we're going to carry on with our creation headlines as well. But I've got the Bible open just to kick things off. Because it's interesting that amber is mentioned 3 times in Scripture. All 3 times are in reference to God's throne room, and all 3 times are found in the book of Ezekiel, right? And so in Ezekiel chapter 1, verse 27, and it says here, also from the appearance of his waist, talking about God right in the throne room, and upward I saw, says Ezekiel, as it were the color of amber, with the appearance of fire all around within it, and from the appearance of his waist downwards, it were the appearance of fire with brightness all round. So Ezekiel is here. He's seeing a vision, right? He's seeing in the throne room of God, and he's got to try and describe in human terms what he's seeing, which is not the easiest thing to do when it comes to describing God. But the really interesting thing is that word amber in the Hebrew is still used today in modern Hebrew, and it refers to electricity. Something bright and fiery, right? Well, you shouldn't be too surprised because, again, you can follow the thread all the way down through history. The Greeks had amber. Now, I've got samples of amber here, right? Beautiful stuff. It's full of bugs and bits, and we'll pull some up on the screen in a minute. But the Greeks worked out that if you get amber and you rub it, it goes all tingly, and you can make feathers stick to it and all sorts. Now, they called it the same word that we use for electric today, and it was indeed electric that they were really using, of course, static electric. But it appears that Ezekiel has one other connection as well, because you see, this is happening at the time when the children of Israel are in captivity, right? They've been carried off to Babylon. And the Assyrians and the Babylonians, who took both the northern and the southern kingdoms into captivity, as was prophesied by God, they loved amber. In fact, we even have some Babylonian amber artifacts here in the Creation Research Museum, and they would collect amber from around the Black Sea in many of the coal beds that you find in that region, and they would decorate it and turn it into all sorts of ornaments, but it was particularly associated with the kings. It's interesting that what appears to be Ezekiel using a well-known kingly description of a beautiful color in reference to what he's seeing in the throne room of God. And as John said earlier, that's a whole study sermon on its own. But our overarching topic today is amber. We've got a lot of content to try and get through. And yes, we want to try and give you a little bit of a glimpse as to just how much amber shows the beauty and the glory of God. And it really does. So we're going to kick things off, though, with a little fun little section that Glenn's going to actually introduce us to, which goes back to that age-old question of, can Jurassic Park ever be real? But anyway, Glenn, over to you.
All right. Let me share my screen. All right. Well, before we talk about Jurassic Park, in 2005, Mary Schweitzer just rocked the paleontology world by proposing that dinosaur bones have soft tissue in them. And that just revolutionized paleontology. And nobody had thought that was possible for fossils to have soft tissue. But it shouldn't come as a surprise. That was 2005. Well, in 1993, Jurassic Park came out. And what was the story of Jurassic Park? There's geologists like John and Joe out there, and they're collecting amber. And what does amber have? It's got insects, it's got mosquitoes. And what did mosquitoes do? Well, they suck the blood of dinosaurs. And so they've got DNA in it. That was the whole story of Jurassic Park, was that there's soft tissue inside of amber. And of course, then they had their whole lab full of scientists drilling into amber. They've got amber everywhere. They're drilling in, they're extracting out the blood. And next thing you know, all the scientists are going, ooh, wow, oh, they're looking at the dinosaurs. I haven't figured out in this movie how they went from the DNA to immediately these big giant dinosaurs, but it was a great movie. The question is it true? Is there DNA in amber that can reproduce dinosaurs? We're going to talk about that just a little bit. Amber, particularly over the last couple of decades, has just been an explosion of soft tissue finds inside of amber. Because, as Joe said, it's not only beautiful, it's got these really immaculately preserved fossils inside. And this is a quote from a curator of the Natural History Museum in New York. He said, right now we're in a frenzy, almost an orgy of discovery. And he's talking about in amber. And in 2018 alone, the amber coming out of just the Burmese amber coming out of Marymore, they found 321 new species. And for the whole of what they have found, just from that one area, it's almost 1,200 new species. It's just this proliferation of findings of fossils inside of amber. What I found interesting about this, because I'd always heard that amber was found, and I think we're going to talk about this, how it's formed, but I always thought that it was found mostly from ocean deposits on beaches. But they're digging down, they said 100 meters and digging out the amber. And the amber, one thing that's nice about it is that it's got this immaculately preserved fossils inside, and they're getting 3D look at the fossils. They're not just squashed like we typically find in the other types of rocks. And they can do, CT scans on these and get these really immaculate descriptions of what's inside of the amber. But the question is, is there DNA inside? There's even fossils like this that they first called it a curious seashell. And then later, after doing the CT scans, they said, well, they think it's an ammonite inside of it because it has the characteristics of an ammonite that they can see inside. So the question is there DNA? Is Mr. DNA real? Can you extract DNA from amber? Well, here's a quote from the News Paleontology in 2019. It says, the Jurassic Park dream of fishing out DNA from amber hasn't yet come true. Now, they do find soft tissue. They find lots of different things, but not DNA as yet. Here's some other quotes. It says, many studies show that DNA degrades quickly, as in the half-life is just a couple hundred years. So even with the young amber, because most of that amber that's coming out of Marymore is considered to be 100 million years old. Of course, that's not true. But even in the younger copal amber, it doesn't have DNA in it. And when it was proposed that they had found DNA back in the 1990s, they've since found that that was just contamination. So the answer to the question, is there DNA in amber that can reproduce dinosaurs? No, or at least not yet. So hold on, they're finding so much amber. And of course, we know the amber is not millions of years old. It's 4,500 years old or less. So stay tuned. I'm going to turn that back over to you guys now.
Yeah. Thank you for that there, Glenn. That's great. If you want to bring it back to us, Sam, and then
It is interesting, though, whenever I show amber and with the insects on it, that's what they're all interested in is Jurassic Park and can we make dinosaurs? That's what I always get asked. So,
All right, I think you want
you
me
have to
now,
remind
Joe.
people that science fiction is called science fiction for a reason.
yes.
But yes, we're gonna go on to John now, and he's going to share us a little bit of a geological background, if you like, to amber, particularly with the reference to amber that's found in coal. And so, John, I think you've got some slides, and it's over to you.
Yes. If you'll put my slides up, that'd be the great way to do it first, Joe. Okay. Now, I first came across amber at university doing geology, and what intrigued me, particularly when I got into creation stuff, was the records of amber in Poland with corals in it. Trees and corals. I can't imagine corals climbing trees to get trapped in leaking amber, but that sort of left a puzzle to me. And since then, as I've wandered around the world, why aren't my slides progressing, Joe? I'm hitting the advanced
You might
button.
need to click on your slides, and then
Okay, let's try that. No, I've clicked on slides. All right, you can tell this is John Mackay, the old guy.
Have you brought your slides up? Have you go down and click on your PowerPoint presentation? You might need to bring your slides up first.
Okay, it should be up there. Okay, how's that?
There we go.
There you go.
That's good.
There we go. Okay, so having had a look at amber all around the world since then, both in the books and looking for it myself in coal fields, because that's what I used to major in and lecture on as well. Okay, you'll see where I live, that big blue dot. This is straight off Google this morning. We're just going to take a little excursion across the pond to New Zealand, which some of you may not know is regarded as Australia in the early documents. The Kiwis are not too happy on that, but there it is. You see two islands, North Island and South Island, and discovered by Abel Tasman long after the Maoris had discovered it. They, of course, have lots in common with the people in Hawaii, similar languages, similar gods, similar religion, and lots of amber. I've been to Hawaii, but I haven't found much amber over there. But New Zealand, well, you can go from the North Island way up past Whangarei. Yes, you heard that WH in Maori is a F. Whangarei, all the way down to the bottom of the island, way south of Queenstown, which is a famous mining town. Now, it doesn't take you too long to go over the whole lot, so put some arrows on here. Here's where I've excavated in the coal fields. Yes, I've been going to New Zealand for a long time now, and it's been really great to go through the coal, particularly with one young man. We were just sort of east of that arrow under Hamilton, and he was telling me as a PhD student, he became a convinced Christian and creationist because in that coal field, he found fossil oysters. Yes, I have some of them. And he said what convinced him it wasn't millions of years old was the fact that when he opened them, the flesh was still in there and they stank. All right. My first experience with amber. Okay, here we are in an abandoned coal mine. You'll see the strata, you'll see the erosion, you'll see the bushes overgrowing the abandoned cut, and taking a picture of both my, yes, that's an old-fashioned camera case. Didn't they used to be big? I used to carry all that around with me, and you'll see my friend Jeffrey. He's standing in it's a log impression. We're right on the edge of the coal. You get a bit closer, and you'll find that in the coal, just under that log, there's big blobs of orange amber, sometimes tiny, sometimes big. Now, this was, to be honest, the first time I'd encounter amber in situ. Yes, amber in Poland, amber with seashells and corals in it, none of which made any sense if you're thinking in terms of millions of years of slow deposition. But here's a coal field, largely plants, largely bark, largely leaves, and in the middle is amber. But do you notice something interesting? It's not nice and round like the polished specimens you can buy from the jewelry shops. This is amber that's just leaked out of a tree because amber comes from inside the tree. The amber was then picked up in the coal. Actually, that means that the tree was still fresh when it was buried. So it could be squashed and bleed amber. Amazing. Okay, some nice specimens. Notice one thing, they're not nice and round. They haven't spent very long tumbling through the water along with the trees and the branches and the leaves. So when you look at amber, New Zealand became famous in the 1800s because they dug this stuff up and had a tiny fragrance, but boy, did it polish well. And when they shipped it back to Queen Victoria and all the others, amber jewellery was the in thing because New Zealand was a British province and they got the amber technically for next to nothing. Well, one of the things I found in that coal mine is still a bit of a mystery to me. Here is a fossil. You'll see the tree on the north side of it. You'll see the coal on the south side of it. And this sharp, pointy thing, well, a bit of a mystery. Take you a bit closer. Yes, I did take it to the museum and I did ask them what it was. And this is the National Museum. And they said, if you donate it to the museum, we'll tell you what it was. Now, that's code for we'll keep it and you'll get it never again. So you're right, I didn't give it to the museum. And I'm grateful that in those days, there were no real restrictions like there are today. I personally suspect it's one of the sharp, pointy edges of some of the turtles or tortoises that have really spiky edges around. But it's a fascinating mystery. Is it a tool? Is it a weapon? Well, it's in the bed with the amber. So you get strange things, you get interesting things like amber that's been squashed out of trees, and it had to be buried basically just after the tree had knocked down, and the tree is still bleeding. Not time, but process. Okay, go up to the north of New Zealand. Okay, I've been trying for ages to get up here because I was in the National Museum there with Dr. Alan Hall one day, and he was personal friends with the then curator who said, come and have a look at this, Alan. And we went and we saw his collection of fossilized coconuts from this beach here. So we made it our aim to get up to Cooper's Beach, and sure enough, in the coal, there's lots of things, not just bits of seaweed sitting on the top. There's these squashed coconuts. Oh, no, not the size coconuts you're thinking of. These are miniature coconuts. New Zealand is too cold for any sort of coconuts these days. Would need real good climate change to grow coconuts there. Well, there's my collection. I've collected several times up there, and the place is full of three-dimensional coconuts. And yes, you're guessing right. All up and down New Zealand, as evidence of rapid burial and rapid formation, are not only the fruits, not only some of the weird-looking spikes, maybe from turtles or tortoises, but also the presence of amber, which produced a fantastic industry. And by the way, we've known about insects and that in the amber for ages, but they took nobody notice in a world where, okay, they all believed in creation. They all believed in Noah's flood. That's exactly what you'd expect to find. Animals, plants, buried quickly, trapped in the amber as it leaked out of the branches, etc. And some weird cases like coral stuck in the amber alongside of the coal in Poland. Okay, yes, some of them come out three-dimensional. They haven't even been squashed. So we've got some fabulous specimens in creation research, and we're sharing them all around the globe with the museums in Oswestry and in Tasmania. So keep praying for the work and throw your support behind it. Okay, back to me now, Joe. Now, let me see, how do I get out of here?
Yep, that's good. We'll take that down. Thank you, Sam. So that's given you a little bit of a sort of an introduction to the world of amber, some of the fun stuff that comes from the movies, and a little bit of the background into the geology. The next big section we're going to do, I'm actually going to take you through a little bit of some of the headlines that we've heard of amber recently, in particular look in reference to climate change and atmospheric levels and all that kind of stuff, a little bit sciencey, before we show you some samples that we've got within creation research. But before we do all of that, it has come time to do our creation headlines, and then we'll have a little bit of a break before we while we answer some questions from you guys and do some thank yous before we carry on. So it is Craig's turn, I believe, to do the creation headlines today. And so Sam, it is over to you to do all of the logistics backstage. And Craig, it's over to you for the presentation. And let's do this week's creation headlines.
Welcome to Creation Headlines for this week, and making news. The evolution of kissing has been suggested by researchers to have evolved from sucking parasites off each other. A paper in the Journal of Evolutionary Anthropology has looked at the various theories for the evolution of the human kiss. Is it a leftover of chewing up food and transferring it to another individual without teeth? Or, as this study suggests, is it a way to clear one's mouth of debris and parasites collected after grooming one another? A practice that's apparently observed in chimpanzees. Researchers in this attempt at serious scientific research conclude kissing is a vestigial action that humans no longer need for hygienic purposes, but have retained as an evolutionary hangover. The kiss as a sign of affection between people of various relationships is seen on many occasions throughout the Bible, including numerous examples in the first book, Genesis. The earliest known evidence of kissing in humans outside of the Bible comes from Mesopotamian art, which suggests that it is a very early behavior of humans. We suggest that an evolution-based worldview will always struggle to explain actions such as kissing or laughing because they are unique human characteristics, reflecting unique interpersonal emotions built into us by our Creator. We also recommend that next time you want to be affectionate with your special person, that you do not suggest you spot a parasite on them that you would like to remove, or you might just cop something else in the kisser. Now, to another piece of Mesopotamian artwork. Recent internet circulation reporting a new discovery of a Babylonian map to Noah's Ark is not as new as some may think. Rather, the British Museum has simply made a curator's clip on the well-known earliest map of the world from Babylon called the Imago Mundi. However, it has generated interest again because of directions it gives to Noah's Ark. These directions were discovered in the 1990s when a missing piece of the map was found within the British Museum's extensive Babylonian collection. Dr. Finkel from the British Museum says that the map describes, quote, that if you went up this mountain all the way, eventually you would see against the night sky, silhouetted the ribs made of wood of the wreck of the Babylonian ark, which, like the one in the Bible, came to rest on a mountain. Of great significance is the mention of Urartu on the tablet, and this is the Assyrian equivalent of the Hebrew Ararat, confirming that the ark being referred to is one and the same as the biblical Noah's Ark. This does not surprise the close observer of history, because 2,000 years ago, Jewish Roman historian Josephus said, quote, now all the writers of barbarian histories make mention of this flood and of this ark, among whom is Berossus the Chaldean. For when he is describing the circumstances of the flood, he goes on thus. It is said that there is still some part of this ship in Armenia, at the mountain of the Chaldeans, and that some people carry off pieces of the bitumen, which they take away and use chiefly as amulets for the averting of mischiefs. Well, these records are what we would expect when the Bible is true. Now to something close to home for yours truly. Researchers have reported in the journal Science Advances that Tasmanian Aboriginals changed the Tasmanian environment by introducing regular burning over 41,000 years ago. They cite evidence from charcoal deposits contained in mud. While we contest the assumptions that they base their dates on, we agree that burning practices modified the environment. European settlers in the early 1800s recorded the ability to ride horseback at night through forest areas that you would battle to walk through in modern times, even during the middle of the day. It hasn't taken Europeans a long time to modify the environment by reducing the burning frequency, just as it would not have taken long for Aboriginals to impact the environment initially by their regular burning. Aboriginal fire in the landscape would not be stopped at roads or farms or by fire engines, so many of their fires would have covered large areas. We also agree with the paper that Aboriginals walked to Tasmania when ocean levels declined during the Ice Age. However, biblical history demands that this was within the last 4,000 years following the dispersal from Babel and not 41,000 years ago. The estimated Tasmanian Aboriginal population at first European contact was less than 15,000 people, and perhaps as low as 5,000 people. If they had been there 41,000 years, they were spectacularly unsuccessful in their survival and population growth, despite their great skill in surviving a difficult environment. However, if there were only a relatively small number who made it to Tasmania before the rising sea levels cut them off from mainland Australia, then the biblical timeframes would fit perfectly with the estimated population size. And that's all for Creation Headlines this week.
Yeah.
Back to you there, Joe.
There we go. That's great. Yeah, none of that worked for me. I didn't see anything at the end of that. It all froze, but there we go. They're great stuff. Thanks for that, Craig. It's time to have a little break while we answer some questions and do some thank yous. So I did see there was a couple of questions that had come in and a couple of thank yous. So yes, do keep your questions coming in as we go. We'll hopefully have time for another question and answer session at the end of our next set of discussions. But for now, Sam, it's over to you for some thank yous and a couple of questions.
Great stuff. First up, we've got Douglas Boffey coming in with a super sticker for 10 British Buckaroos, a pair character jumping up and down and saying, "Number one fan, number one fan, number one fan." We've also got Fiorella Clerk coming in with 3 CHF Buckaroos, Sheba Dog raising an arm to greet someone, asking, "How's it going? How's it going?" Right, okay. Move on to question. This one comes in from Fiorella. How big is the biggest animal or others that has been found inside amber?
Joe?
Well, one of the biggest that I've come across has been a lizard's foot, which is probably a good 2 or 3 centimeters in length. That's been found inside of it, complete with all the scales and everything. You've got to remember with amber, it is effectively tree resin that has been fossilized and has undergone what is in essence a chemical change, and so it's effectively a plastic. In the sort of the chemical terms of what a plastic is, not in terms of something artificial or man-made, but you are then limited in the amount of stuff that you've got to fully encase and preserve something, because even if you partially encase something, and there's still air able to get into that creature, it's just going to rot it away. And we do sometimes find larger things or impressions of larger creatures that kind of have been smushed into amber, that have been rotted away or destroyed, and you end up with just almost like a cast of that thing. But the largest things that I know of, bits of twigs, bits of trees, a bit of a lizard's foot, but we're talking moderately small stuff in the grand scheme of things. Do you know anything bigger, John?
The frog was 3 centimeters that I showed.
Yeah. The thing you need to think through is if you have a lizard's foot, a significant several centimeters across, what happened to the rest of the lizard? And when you look at the amber material itself, you've got trees that have been knocked down, washed along, still living or still alive, still able to bleed stuff that's bleeding it out on other creatures that are trapped in there with it as well. So how far they were traveled, we don't know, but it means that the rest of the lizard is probably not just rotted away, it's torn away. So those are the sort of things you need to look for inside the amber. And what did you say the size was of the piece you were talking about?
The frog was 3 centimeters. That was the biggest one that I saw. But anything that's large can pull its foot away from the stickiness of the amber. So you're going to catch something that's just not strong enough. It's going to stay stuck to the amber. So
or it's already dead.
Or it's already dead. Yeah. And
That's
you
what
saw
I
the
think.
snake that I showed. It was wound around, but it was still in a piece of amber that I think was like 2 centimeters long. So very tiny.
Great stuff. We'll move on to our next question. This comes in from Who Little Old Me. Question: if DNA has a half-life of a couple of 100 years, what would be the maximum life? Less than 970 years? Do you see where I'm going with this?
Well, I remember one of the years I was doing work at Queensland University. This was sort of just back when Jurassic Ark had come out, and all the students had questions about exactly that. Would you still have real DNA? And one of the papers that was published in the university at the time, it utilized the concept of DNA half-life and said there's no way it would survive millions of years, let alone hundreds of thousands, let alone thousands of years. And so the professor was quite angry at the producers of the movie, saying they didn't base it on real science at all. But then again, since their Velociraptor is as tall as me and the real ones are only this big, there's not much science there at all.
It's called Hollywood.
Oh, sorry about that. I missed that bit.
We are getting closer and closer, though, to uncovering DNA, which is in fossils that are supposed to be millions of years old. If you think about DNA and like any kind of biological material, there are ways of extending its shelf life, but you're still limited on how far you can actually extend that shelf life back. Right. So we've got to the point where we're fairly well versed in not reading DNA, but DNA leaves marks, basically markers on proteins. We're able to find the proteins, read and sequence the markers on the proteins from the DNA. And so you basically get a protein sequence. It's called proteomics, right? We've been able to do that to bones going back to the Triassic. So we're talking 300 plus million years old, right? Supposedly, and far, far beyond even proteins are supposed to be able to have survived, things like collagen, right? So we're getting closer to DNA. We're not quite there yet. There's been a number of claims of research that's been done using various staining techniques, forensic staining techniques, which stain a certain color if there's DNA present. And they've tested this on some dinosaur bones, and they have shown positive, but that tells you nothing about the quality of the DNA or whether it's anywhere near enough to be readable, right? But we are getting closer and closer, and the fact that we're even able to find proteins themselves or any organics is remarkable. The fact we're able to find proteins that are in enough, in a state to be able to be read and to actually have the markers of DNA, we're just getting inherently more fragile. And it just goes to show that there's simply no way that these things can be the ages that they're purported to be.
Joe, I noticed there's a comment there from Alan Pfeiffer, who was at our museum from New Zealand a couple of weeks back, and he mentions kauri gum was and is still a big industry here. I remember being down near Lake Taupo, which is a volcanic caldera type formation, and there's big forestry fields around there. So I got permission to actually go in and excavate it, and I had a forestry guy come with me, and we found some fabulous trees, particularly some of the pine trees and things like that, the kauri, and some good gum. And I said, I'd like to take some of this back to Australia. And he said, well, it looks like it just died last week, so I'll have to certify that this was actually dug up in a volcanic deposit. And I was just noticing the other day, it's still sitting in my fossil shed there. And you are right in the fact that the kauri gum, not only up there, but up past Auckland as well, is actually full of this stuff. And it really still is a decent sized industry in New Zealand. So thanks for the reminder.
I've got a little bit of sample of kauri gum here, John. I don't know if I'm trying to get into focus, see if we bring it really close, whether that'll do it.
That's too close. Too close.
Yeah.
That's better.
There we are. Now it's in focus. There we go. So you can still see some of the bark and stuff. This is basically the fossil stuff in the sense that it's been dug up, right? But you can still see the bark there. And if I carefully tilt it around trying to keep it into focus, you can see some of the amber that's there, the gum, so to speak. So, praise the Lord for good samples, hey?
when I was around Mount St. Helens, where I've been many times, you could always tell the trees and where the volcano was because the majority of damage was on one side of the tree, the side facing the eruption. And that's how you can plot where the eruptions were in the New Zealand trees as well. One side is damaged, and that's where your gum first leaks out. It did it at Mount St. Helens. It did it in New Zealand. So kauri is not just interesting, it's an indicator of directions. It's an indicator of animals that get trapped immediately afterwards. So very, very fascinating indeed. Thanks, Alan.
Yeah. All right. Well, let's leave questions there for the time being. We'll come back to some more later and keep your questions coming in. But for now, let's carry on with our program. But just to kick things off quickly before I bring up my PowerPoints and all of that, Sam, if you can just bring up my second camera there, because what I actually have next to me is a little microscope. It's a little digital microscope that we got for the museum a little while back. And Sam, if you can just put that up to full screen, there we go. You might just be able to see. Let's move it around a bit and try and get a bit more brightness going. There we go. You might just be able to tell what it is. It's a piece of amber. You can tell by it's amber colored, isn't it? But if we have a look and see what's inside it, I'm just going to pull it out. This is live, by the way, guys, so I have to sort of go along and adjust it with its focus as we kind of go. But you might just be able to spot what's there inside of it. If you thought it was some kind of feather, you'd be absolutely right. So let's actually zoom down a little bit closer, by the way, and you'll be able to see that when we're dealing with feathers in amber.
There we go.
What's that, sorry?
You'll have to.
Yeah, as I zoom in, I have to focus it manually as I go. So we'll bring it down, but you'll be able to see that you don't just have them get in feathers. You get the little veins that come off, and eyes. You can actually see little barbules. You can actually see the little barbules which are connecting that feather together. Now, this is one of the feathers, one of the many feather fossils that we have in amber in our museum collection. We sent some over to John with Diane the last time she was here. Craig has got some, and in fact, this exact specimen is not staying with us. This is actually going to Professor Andy McIntosh because he expressed some interest in getting hold of some feather fossils in amber because, his background is aerodynamics, right? And he's very good at that kind of stuff. He's got some fantastic talks about birds and feather design, and he specifically wanted one of these feathers in amber because you see, and Craig can testify to this, when you get hold of these, both in the academic world as well as in the trade world, where you get hold of these things from Burma, the Burmese amber, right? These are claimed to be dinosaur feathers. Now, how do we know that they're dinosaur feathers? Well, the reality is you can ask around, you can try and find out as much information as you can, but the prevailing argument, the main argument, which is the only argument which really holds up, some claims around feather structure and the like really don't work because you see birds have exactly the same feather structure that you see here, even down to the little fibrous type feathers, right? The only argument that you really have for these being dinosaur feathers is the fact that they are in amber, which is supposed to be around 100 million years old. I mean, it's 99 million years old, give or take 3, right? And the argument is that 100 million years ago, the only the prevailing feathered creature was a dinosaur. And it really does hone in on this question then of not only dinosaur evolution but also feathered dinosaurs. And it's actually interesting, we've been blessed with these feathers here, and Andy McIntosh, who's a friend of the show and a friend of Creation Research, is actually wanting to do some work with us on combating some of the claims around feathered dinosaurs and the like as well. Well, let me move Andy's one out of the way, and I'm just going to put in a couple of other samples for you to have a look at. We've got another really big one here. Let's just get it under. There we go, and get it into focus as well. You can just start to see just how detailed some of these amber feathers actually are. Here's another example, which we've got in our museum collection. Let's see if we can get it into focus. There we go. Hey, look at some of these details. Absolutely beautiful. And Diane, you're the sort of resident biologist on the team. Do you want to comment just on how clearly these feathers show feather structure?
Yes, I've actually looked at these specimens in one of my previous visits to the museum. And yes, you can. You have to focus up and down clearly, but they have all of the features of bird feathers that you would see out in a living bird. So there's no dispute as far as I'm concerned. These are bird feathers. They have all of the features of bird feathers. And we have several specimens of them, yes.
And it's very clear when you see something like this, right? Look, with a long central midrib and the little ones coming off, and even the barbules going in between. But if we stick a sample like this under, Diane, which see there's this sort of spindly little feather there. Let's see if we can zoom in a little bit more, okay? And the claim is that, well, actually these little spindly feathers is what we'd expect to see in a dinosaur type feather, in these sort of, you know, proto feathers that dinosaurs were supposed to have. But in fact, there are birds with feathers today that have feathers even like this, correct?
Yes, particularly baby birds that are still growing. They have sort of little fluffy feathers that don't have the complete structure of flight feathers, but they're very clearly bird feathers. So there's no evidence here that this had anything to do with a dinosaur. And you do have birds, particularly young birds, juvenile birds. They have little fluffy feathers like this. And so there's no excuse for calling this a dinosaur feather. If it was found in something that was dated with a lesser date, they would be called bird feathers.
Yes.
Or if there was evidence of birds in the area that it was collected, but in fact there's no evidence of either birds or dinosaurs here. So it's purely a belief based on the long ages.
So there's no real argument then. So go ahead, sorry.
Yes. And the fact that people want to believe in feathered dinosaurs. And so they will grasp at any evidence that they get, but there's no evidence that actually stands up genuine scientific scrutiny that these are dinosaur feathers.
And in fact, you can just see, I'm just trying to get it into focus here. We've got another type of fossil. I know that Craig's got a similar one to this. It's another one of those snaily type fossils. The first time putting it under the microscope, if you get the angle just right, it doesn't look very snaily like inside, because you do have multiple chambers. So who knows, we might even have one of these ammonites ourselves here. We need to investigate it a little bit more, but assuming you can just begin to see, if we try and move around, I'm just trying to move the light around, you can kind of see the chambered structure there. But even if this is just a snail shell, you know, one thing for sure, it looks like the modern day aquatic snails. And so if it is a snail shell, they haven't evolved, no matter how old you want to make this amber, even up to, in this case with the Burmese amber, it's supposed to be 100-odd million years old. Moving that out of the way, and I just want to show you two more quick samples before we go to our big presentation. We've got one very large piece of amber here. You can see it's... I can't even fit it all in one piece under the screen, but I just want to show you just sometimes how much stuff you can get into a single piece of amber. It may not be very big individually, but boy, are they full of different things. We've got everything in here, from little bugs to beautiful. You can see that lovely leaf, not leaf, sorry, the wing vein on that creature just in the center there. Let's move it around a little bit more and see what else we can find. Water bugs over there. It's just absolutely full of creatures. It really is a mass burial for sure. Beautiful, great big creatures. And of course, these are all great indicators, not only of how quickly it was buried, but also the fact that there's a little mosquito down there. You see it just down there? Yeah, pretty nice detail that you can find in some of these. So you can have hours of fun just sort of playing around and finding out what's inside your amber. But in the case of living fossils, I've got one more thing to show you. I believe it's these ones down here, but I'll just see if I can get them up to double check for sure. I don't think it's this one. Oh, there's a little mosquito there, but that's nice. But I think it's this one just down here. Let's see if this will get into focus. Okay. Whoops. There we go. Hey, can you see what that is? A little bit wobbly. See if we can get it into.
The spider.
There we are. Whoops. There we go. Yes, we are indeed looking at a spider. Let's see if we can get it into focus. Hey, look at some of the detail of this. By the way, these are effectively the creatures themselves that are completely encased and entrapped. They haven't turned to stone or anything like that. You've basically got the creature as he was crawling along the branch before he got caught up and actually buried and preserved in the amber. So, yep, there's no evidence of spider evolution either. But, John, you've been to the Sedgwick Museum as well as me, right? And you've seen some of the fossil spiders that they have there, and well, they're not quite as small as these examples, are they?
No, ancestral spiders, like many ancestral creatures, were max in size. My wife would have hated it, unless, of course, you could have one as a pet and pat it. But she's so phobic about spiders that they certainly were bigger, and you do see a devolution as well as after their own kind. And of course, when you look at the legs of this, it obviously wasn't crawling up a tree as the amber leaked out of the tree, right? These all show indications of being pushed by fluid, water, or wind and put into the amber. And the amber is leaking fast enough to cover it before it can A, pull itself out, or B, bits fall off where it's tried to pull itself out. They're buried intact.
Yeah. All right, well, we'll get to some more examples a little bit later, and Craig's got some stuff to share with us. But, Sam, if you want to close down our microscope and bring up my PowerPoint, because on our PowerPoint, when I do a program that I haven't done in a little while, or a program that we haven't done before, I like to just go onto Google and stick the topic into Google and then click on the news button and see what comes up. Of course, I put amber in and then clicked on news, and the first sort of 50 results hits were all about the amber weather warning that the UK is having currently, because it's currently a balmy -4 degrees centigrade outside. But there we are. This was the first relevant amber headline, right, on the 15th of this month, 6 days ago. Another piece of the puzzle. Antarctica's first ever amber fossil sheds light on dinosaur era rainforest that covered South Pole 90 million years ago. Okay, what is the actual paper? Well, it was published in Antarctic Science, a journal all about Antarctic science, strangely enough, and it was published online by the Cambridge University Press. You can go and check this out yourself. Published just about a week ago on the 12th of November, and this is what they had to say about the first discovery of Antarctic amber. The first discovery of an Antarctic fossil resin, commonly referred to as amber, in what is effectively a fossil layer. There's the pictures from the report. There's Antarctica, where it was supposed to be 90 odd million years ago, with its land bridge. And on the right hand side, you can see, well, we're dealing with a pretty tiny little layer of, a tiny little sample of amber in a little sample of what is basically brown coal, right? Partially petrified coal. It's got little tiny fossils trapped inside the amber, which you can see on the far right-hand side of the picture there. Little bits of twigs and fibrous things. Well, this is what their report said. The palynomorphs, which are basically very small fossils, right, preserved in the carbonaceous mudstone, that's coaly mudstone, right, carbonaceous, like the Carboniferous, containing the amber-bearing coal rocks, indicate a mid-Cretaceous, swampy, temperate rainforest environment near the South Pole that was dominated by conifers. In other words, if you put it into regular English, microfossils and amber in Antarctic rocks tell us that there was once a rainforest at Antarctica. And you remember the headline? It gives us a new insight into what the climate was actually like. You see, Antarctica today has no trees. It's covered in ice and snow. An average interior temperature of -43 degrees. Hey, that makes it feel pretty warm here in the UK, despite our winter temperatures. and you've also got desert conditions there. Only 166 millimeters of rainfall per year. Yes, I know we often associate desert with heat, but desert is just a reference to how much rain there actually is. Only 166 millimeters of rainfall per year actually puts Antarctica as a desert, and a very, very cold one at that. You see, this description of Antarctica, which we can go and see today and observe it today, sounds very different to the one described in the fossils that you find there. Oh, but this isn't actually that unknown or unusual, because you see, it's maybe the first ever record of amber from Antarctica, but the first explorers there collected fossils, and they recognized that the fossils that you find there, beautiful ferns and all sorts, had to have come from a time when Antarctica was actually much warmer than it is today. You see, the fossils that you find there, including this new amber discovery, is all an indication of climate change. It used to be warmer, now it's much cooler. In fact, you've got fluctuation of climate change in historical records over the last 2,000 years. That was one of the lectures that I gave, by the way, to the academics in Poland that I was visiting recently, when we were talking about the historical side as well as the scientific side of climate change. Well, here it comes both together in the fossils, right? You've got both a historical record as well as a scientific indication that climate has changed in the past and it will continue to change in the future. Okay, so what is amber and what does it show? Well, amber is effectively just fossilized tree resin, right? It's indicative of ripped up pine trees, because you see you need damage to pine trees in order to produce vast amounts of sap and resin to actually be fossilized. So don't be surprised that often when you find amber, you find an indication of, if not just ripped up trees like coal and the like, where the bark has turned to coal, but even log jams and things like that, or even the kauri gum, where you've got indication of a catastrophic burial of trees, which has ripped them up to actually produce the sap, to bury it, to turn it into what is effectively fossil amber. Certainly indications of rapid burial under conditions that are suitable for fossilization. Otherwise, it will just stay the gum, or it might harden into what's often known as fake amber or copal, right? Often referred to as young amber. Most of the bug inclusion type amber that you get from your sort of high street fossil shops are going to be copal, right? The sort of semi-fake amber. But the true amber, the Baltic amber, the Burmese amber, and the like, often contains inclusions. We've seen examples of them already, both plants and animals, and also air bubbles. Now, it's the air bubbles that we're going to focus on in the next little bit. Here's a sample of amber full of air bubbles. Look close and you see all the bobbly bits? They're all air bubbles. And in fact, these were part of our museum collection, and these have actually gone to a fellow student who is doing some research on them. Why? Well, he's trying to replicate a experiment, or a series of experiments that were done back in the 1980s, and the authors have been defending their research ever since. Now, what's been interesting is that despite having an awful lot of criticism of this research, even to the point where many mainstream creationist groups have said, well, we're not going to use this research because it's so controversial, and despite the authors actually publishing around 3 additional papers basically justifying their experiments, nobody's ever thought to try and replicate it or to retest it. Now, I wonder why, and I suspect politics has a lot to do with it, but that's actually what we're trying to do with this amber sample here. So yes, cutting edge research, all exciting, but the claim is that amber air inclusion, so these little air bubbles inside amber, are going to contain a record of the atmospheric conditions at the time that the resin was preserved. So what is actually found if you analyze this air? Well, you analyze it using mass spectrometry. Specifically, if you want to look it up, it's time-resolved quadrupole mass spectrometry. And effectively, you put the amber into a vacuum and you remove all gas and air. Yes, it's fairly sophisticated techniques that are needed, because you also need a mechanism while it's inside the vacuum to actually crush that amber up. Why? Because in doing so, you're going to release all of the air that is inside those bubbles. You then analyze the gases that have been extracted from that amber, which are now in the vacuum, and you can get a mass spectrometric sequence, which will tell you effectively what gases are present in that vacuum now that you've crushed the amber and added some gas to it. This is basically what they found. You can see the reference down there, 1988. Well, there's a list of gases on the far left-hand side. There's the composition of modern air, and then you have this Cretaceous Cedar Lake amber that they tested. They actually tested a number of different ambers, including Baltic amber, but this was one of the more significant ones. You see nitrogen there, N2. Well, nitrogen in modern air around 78%. It's the majority gas, but there's only 59% in the Cretaceous amber that they tested. Oxygen, 20% in modern air, 23% in Cretaceous, slightly higher, but the most significant one was carbon dioxide. You see it there, CO2, less than 0.1% in modern air. It's a tiny fraction. By the way, before you get worried and scared about carbon dioxide increases with the claim of modern day climate change, and we're not going into that in this program, we don't have time, but we are talking minute amounts. And yet in the Cretaceous Cedar Lake amber, it was 6.8%. That is quite significantly higher. I wonder what it tells us about not only atmosphere, but also about what the plant life would be like if an atmosphere was like this. Well, you see, there was a number of rebuttals against it, if you like, people who didn't like this claim, particularly in reference to modern climate change, which was slowly starting to be a thing back then, and increasingly more so, even to the point where a number of creationist sites say, oh, well, we're not going to make the argument for amber. Well, it's interesting that many of the creationist sites that say we can't trust this data are doing so in response to criticisms or claims around things like the canopy theory. Well, in my head, the research that's been done for a denser atmosphere and any argument you want to make to a canopy theory are completely different arguments. And let me show you just where I've come to my conclusion about some of this research. You see, one of the criticisms that was given against this paper was that, well, amber will leak air out and it will let modern air in. In other words, it's not a closed system, right? You're going to leak air out, leak air in. In other words, you're getting a mix of air. You're not going to be dealing with an accurate representation of what the atmospheric gases were like at the time. Now, remember, the original research was done by these scientists who, by the way, were associated with both Yale University and the United States Geological Group, right, study. So no small backwater scientists. They're fairly mainstream. And it was actually in 2018 that they gave a really long and detailed rebuttal to some of these criticisms, and it's well worth reading. You can see the reference there if you want to go and look it up. But these are what they were basically arguing. You see, one of the biggest evidences that what we're actually looking at is a accurate representation of what the atmosphere was like is that the amber inclusions actually contain gases which are known to have come around from the fossilization process and not from the atmosphere. Methane being one of them, high concentrations of methane, which comes from, decaying organic matter, for instance, and also hydrogen, right, which should have dispersed if amber really does leak and let in new gases, should have equalized. There's a lack of diffusion consistency across amber samples. So you've got a consistency there, if you like. Pressure gradient is not consistent with diffusion. When you look at the amber bubbles, they've certainly been squashed as the amber's been squashed as it's been buried. In other words, you've not got amber behaving like a sort of a liquid where it moves over time, bearing in mind that these ambers are supposed to be millions of years old. There's no difference in the composition between clear and red in amber. One of the arguments is that the red comes from oxidation. Well, you can analyze it, and the composition is exactly the same between the two. So the coloration must come from pigment, not from oxidation. Therefore, you've not got any evidence of an open system there. And originally, there was only a few samples tested. The rebuttal came back with over 300 tested samples of amber, which all showed consistency amongst them. In other words, this is now a fairly well-studied piece of research. The results that were shown, you see Cretaceous atmosphere composition, if these results are accurate, you have 35% oxygen compared to a modern 21% composition. Nearly 5 times as much carbon dioxide in the atmosphere, with 2,000 parts of carbon dioxide per million compared to today's composition of 427 parts per million. And this is all, by the way, consistent with what we see in the fossil record, which which records an almost global tropical environment and far greater volumes of vegetation that we see today. This is correlated not just with the amber results, but also with the fossil record. Journal of the Geological Society. Yeah, now that I'm in as a fellow of the Geological Society, you can get access to an enormous amount of literature, which is wonderful, that I hadn't had access to before. This was reported around the same time that the research on amber was being done. There is overwhelming evidence based on the distribution of distinctive sediments and fossils and of oxygen isotope data that the climate of the Mesozoic world, that's the dinosaur era world, if you like, if you read the rocks in an evolutionary time frame, the climate of the Mesozoic world was appreciably more equable than of today, with no polar ice caps. Except for an episode of late Cretaceous cooling, there's no good documentation of any significant change in global temperature distributions through the era. The distribution of coals and evaporates, together with other criteria, indicate a pattern of humid, arid zones appreciably different in important respects from that of today. Now, that's a lot of scientific words to basically say the climate was much warmer in the past, particularly at the time of the Mesozoic. Here's an interesting little comment here, which is a more recent paper regarding the way that climate has changed. Atmospheric carbon dioxide concentrations appear to have been considerably higher than modern levels during much of the Phanerozoic. That's ancient millions of years history, okay? And hence has been proposed that surface temperatures were also higher. If large changes in atmospheric carbon dioxide did not produce the expected climate responses in the past, predictions of future climate and the case for reducing current fossil fuel emissions are potentially undermined. Are results consistent with warm climate mode for the Jurassic and Cretaceous, hence support the view that changes in atmospheric carbon dioxide concentrations are linked with changes in global temperatures. In other words, somebody has pointed out to them something quite significant. You see, if carbon dioxide and that the atmosphere, the climate was much warmer in the past based on the fossil records. If it didn't have anything to do with carbon dioxide and plants being able to grow better, then they've got a bit of an inconsistency if you want to argue that you've got to get rid of CO2 today in order to fix climate change. So they're almost backtracking here with some of their arguments in order to say, oh, well, yes, of course, if the atmosphere was warmer, then CO2 levels must have been higher. Of course, it works the other way around as well, because higher CO2 levels seem to almost be the cause of the good plants and good climate that you have recorded in the fossil record. Now, all of this is coming together, and by the way, you can look up lots and lots of these references and follow them through if you want to find out yourself. This isn't just me saying stuff. But all of this is pointing to one very important point. In the beginning, when God created the heavens and the earth, everything was very good. And you and I view good as a moral word, which it is, but it's more than that, because God described what he meant by good, and Adam and Eve were naked, and they didn't get sunburn, cancer, and they didn't freeze to death at night. So by default, the climate was very good. So don't be surprised that as we look into what appear to be records of effectively the atmosphere and life on Earth before any major change to the climate that happened at Noah's flood, which is your first ever mechanism for major change in the climate, we see lots of evidence that the world was very good, particularly in regards to its climate and the amount of plants and the higher concentrations of oxygen and carbon dioxide, which overall make for a much healthier atmosphere for both animals and from plants as well. By the time you get down to the end of Genesis chapter 8, God promises none shall remain. There will be seed time, harvest, cold, heat, summer and winter. Now, not only do you have your first ever reference to climate change, you have a world that's gone from good to bad to worse for sure, but you also have a promise that there is no such thing in the future as global warming caused by man. Now, the only global warming that there'll be is when the earth turns to fire, and it won't have anything to do with man other than being God's judgment on man's behavior. By the way, do come and see the museum. We've got some great fossil examples in amber, some of which we've shown you just today, including some of these beautiful feather fossils. I mean, there really is some absolutely remarkable stuff that the Lord has blessed us with, and some of these spider fossils which show that evolution simply does not work. Hey, look, there's lots of little amber bubbles, air bubbles around that spider. I'm not sure we're going to be crushing this anytime too soon to test it, but it's wonderful what God has been able to provide us with, as well as give us insight into the world that he made back in the beginning. Well, I'm going to finish it there and go over to you, Craig, because you've got some stuff to share as well about amber, as well as some of the samples that you've got in your museum now as well.
Well, they're not going to see much compared to yours, Joe. You're just showing off, really, I think. You've obviously got a really good source of amber supplies, or you've spent a fortune on them, because they weren't cheap for us to buy and get them across to Australia, that's for sure. But we did get some because we wanted some in our museum as well. So I'll just get those slides up. Oh, sorry, I'm in the wrong spot, am I? Are we up there okay?
Yep.
Mm-hmm.
Yep. Okay, sorry. So, yeah, here's a feather that we got. So we've just seen plenty of Joe's feathers, but that looked like a nice, almost sort of complete small feather. So I chose that one. That looks like a good sample to have. We also have this snail, which could be potentially an ammonite type creature as well. And I just wanted to go up the top one. There it is. There's a scorpion that we got. And the interesting thing with all of these creatures that I've seen so far is they're recognisably creatures that we know today, and they haven't changed no matter how old you want to say the amber is. So it's recognisably a scorpion. And we get plenty of scorpions in Tasmania. I find them in my firewood heap all the time. They're creatures that love to hang out in trees and under bark and eat wood detritus and so on. So they're a creature that you'd expect to find caught in amber if the flood story is true. So there's two essential requirements for amber formation as far as I could see, and I'm not going to go into the detail that Joseph did, but for some of us dummies that don't know as much about this sort of stuff, this might be a good little summary. But the research that I did said that amber must form in a marine environment. I'm not exactly sure of the reason, and the team might like to comment on that in a moment, but the environment needs to also be oxygen free as it's forming, I guess, into amber. This is not the resin part of it, but as it turns into amber. So the creation model for amber formation in summary is as such. You've got these mass floating log mats of the destroyed forests in the flood process, the volcanoes, the flooding process, the forests are ripped up, and that is where you get your abundant resin source, such that we can even mine it in locations and find it all around the world now. So the abrasion and damage and the weeping of the bark, you can imagine that was happening in these large log mats causes a mass release of the resin. You've got all sorts of creatures, insects, maybe even a few birds have flown and landed on these log mats, or were crawling out of hollows that they were nesting in or something, and small vertebrates even crawling on the logs get caught in some of these resin, or they die and the resin entraps them anyway. The floating resin in the actual water, because you've got marine creatures that are being trapped. These are all very, very difficult things for evolutionary understanding to explain, by the way. But the floating resin traps the marine creatures as well. The resin on the log mats is dislodged, and it drops into the water and then settles in sediments and then gets covered over more, and it hardens under pressure as it's buried deep. And that's why some of these amber samples, I guess, are somewhat warped too, Joe. And there's no change. We don't observe change over time in the trapped creatures, and that is actually reflected even in a Twitter post that Elon Musk commented on a few years ago. There's a gecko that's been trapped in amber, and the post says that that's 54 million years ago. Well, geckos are still geckos. And it looks actually, if you look really closely at his leg there, that he might have lost the end of it. I'm not 100% sure with that, but that might be one of those examples of how you get a foot caught in another piece of amber, perhaps. But even Elon Musk says, well, that species has stood the test of time. So millions of years, no change. Gecko's still a gecko, and even Elon Musk recognises it. So that's just a brief summary. Joe, you can come back to us. Thanks, Sam. That I thought might help some people as a bit of a summary, and just to let you know what we've got out there.
Good stuff. Well, we're going to finish before we come back to answer some questions and go through some more things. We're just going to drop over to Diane for our last little section, because Diane, we have a newsletter that goes out which contains lots of evidence, and a bit like our creation headlines, but in a bit more detail. It goes out every couple of weeks, and the reports that we get from that end up on a website, which you're going to take us through now. So just remind us what that website is while we get your slides up, and you take us through a couple of these reports.
Yes, that's our fact file, which is just an archive of the science news items that we've written about in our newsletter. We just keep a watching brief on what comes out in the science news sources that are sent out to the general public. So we're looking at things that are being sent out for everyone to read, and we make comments about them. We try and trace them back to the original scientific reports in the journals and science sources if we can. These get stored on the fact file, so you don't need to know when the newsletter came out if you're interested in a particular topic. And we have actually written quite a fair bit about amber, because it's something that does appeal to the general public. So if we can just have a look at my slides, I'll just run through a few examples, but we've actually got quite a few more. So one of the things that Craig has just mentioned, even Elon Musk can recognize that the things that are preserved in amber are the same as the things that you might see running around alive today. So between when they got buried and when they're running around in the world today, they haven't changed. In other words, they're classic examples of living fossils, and there are lots of these in amber. And here are some examples that we've written about. Some scientists claim they found the oldest rainforest frogs. They found 4 specimens of frogs in Burmese amber. Now, that's been mentioned a few times in the program. It's usually dated as 99 or 100 million years. And the interesting thing about these frogs is that they had features in common with some living frogs and also some extinct frogs. So they were a bit different to some living frogs, but they were very, very clearly frogs. There was no no dispute about what they were. And here they were. And the other interesting thing is, because they were considered to be a new species of frog, they were given a new scientific name, which had this wonderful name, Electrorana lemay. And Electrorana, if you break that down, remember electron, from what Joseph was telling us about, how the ancient people named amber to do with electricity, and it is still a name that refers to amber. So Electrorana is a scientific classification for frogs. So all this means is amber frog, and the species name there refers to the person who found these particular specimens and passed them on to the scientist who discovered them. Now, these look pretty fragmented, and they are a bit, but these days we are now able to scan fossils and get a lot of the microscopic details, so we can see a lot of the insides of them as well as the overall outline, so we can learn a lot about exactly what these things are, and there's no doubt that these things are frogs. Now, this frog was considered to be the earliest direct evidence of frogs in wet tropical forests. Burma, of course, is in the wet tropics. Now, they are not the oldest frogs or oldest fossil frogs that have been found. And as one of the scientists who studied them said, well, frogs have been around on the Earth for approximately 200 million years. Now, the exact date of the oldest fossil frogs, that's frogs buried in rock, is somewhat disputed, but around 200 million years is a reasonable round figure. Now, if he was right about that, well, the oldest frogs are identified as frogs in the fossil record. That means that frogs stayed frogs for 101 million years before these amber fossils formed, and then frogs have stayed frogs for 99 more million years. So frogs have definitely multiplied after their kind, and the amber frogs have confirmed that. Now, let's move on to dinosaur age. We've had a bit about dinosaurs. People have come to link amber with dinosaurs, and a well-preserved crab was found in some Burmese amber, dated 100 million years this time. And the interesting thing is that this crab had very well-developed gills. So that indicated that it was a marine crab, in other words, a sea-dwelling crab, and not a tree-climbing land crab. Now, there are such things as tree-climbing land crabs, and we have to remember, right, if amber is fossilized tree resin, what is a sea-dwelling tree crab doing up a tree? Well, there were various excuses as to why they could find a marine crab in a place that is fossilized tree resin. But let's just have a look at this crab. See how well preserved it is. Now, there is no doubt that that is a crab. And again, because we now have really good scanning techniques, they can actually see the internal structure as well as the outline. So there was no doubt that this was a marine crab. It had gills, it didn't have lungs. But anyway, they were confronted with, well, how do we explain this? And so they thought, well, land crabs do exist today and they do climb trees, but land crabs actually lay their eggs in the sea. And so they suggested, well, maybe this amber crab was a juvenile that was still just emerging from the sea. But then this is where the evolutionists tie themselves up in knots, because they are wedded to these very long ages. And one of the scientists actually expressed this problem. In the fossil record, non-marine crabs evolved 50 million years ago, but this animal is twice that age, so doesn't fit into their nice evolutionary story. However, we think we can solve that problem. Let's just throw out those dates and look at what they actually found. Let's look at the actual evidence. Crabs that have gills live in the sea. Burmese amber also does contain other sea things, other sea-derived things, and seashells, corals, seaweed, other marine creatures have all been found in Burmese amber. So finding a marine crab is not really that sort of drastic or unusual in terms of the types of creatures you do find in Burmese amber. So a good suggestion would be that this is the result of some catastrophic event that made the sea flow over the land, smashed up some trees, and some marine creatures were caught in the resin. I'll leave you to think what that might be. Now, what about in Australia? We've had Australia and New Zealand mentioned here, Tasmania and New Zealand. And here is a very recent study. In fact, we only wrote about this one a few months ago, where some scientists had looked at amber from multiple sites in the southeastern part of Australia, in Victoria, that's the southeastern part of the mainland, and in Tasmania, which is a little bit further south. And these different sites had different evolutionary dates, varying from 230 to 40 million years ago. And they found a wonderful collection of all sorts of inclusions: plants, fungi, insects, spiders, springtails. And they published their results here with these beautiful pictures here of liverworts and mosses and spiders and springtails and flies and ants. So lots of different kinds of living things, plants. No fungi in this particular picture, but there were in their report. Lots of different arthropods, little creepy crawlies of all sorts, flies and ants. Well, remarkably, these insects are still around in Australian forests today. This was a comment that the scientists who studied these pieces of amber commented, and tracing their lineage back to the time of ancient Gondwana, which is an evolutionary name for what the Australian continent used to be part of. And then they made this interesting comment: without realizing it, we exist among living fossils. Well, how about that? We've been telling people that for a long time at Creation Research. But then they went on to make some of this comment: while we know these species were widely distributed in the past, today most of them are only found on this continent. So something has changed from when this amber was formed to what's happening today. And when these species were fossilized in other parts of the world in different circumstances, not necessarily in amber. So what's happened? They used to be widespread. They are now less widespread. They are now confined to Australia. So we have had change, but we haven't had any evolution. And if you would like the original references and links to those three stories, plus a whole lot of other ones, you can read about all sorts of interesting things found in amber. And there is a sort of common theme: unchanged lizards, unchanged microbes, the oldest amber arthropods, things that are not primitive, even though they're considered to be extremely old. They look modern. Again, the interesting combination of tree amber and sea creatures, and of course the current debate that's going on now: are there dinosaur feathers in amber? We have written about that, and you can find all of this on the Creation Fact File, and maybe we could just put up the link for that, and if we could come back to us now as well, if anyone would like to add to any of these.
Well, Joe, before we do that, how about I put up my dementia thing, because they're related?
Yes, indeed.
Okay. Just briefly, you can take Diane's screen off there, I guess, so you can see me whole screen, please, Sam. Where's Sam gone?
I'm not sure. I'm going to try and fix it and see if my...
There we are. That's good.
There we go. Yeah. Lovely.
Okay. Last Sunday, I was preaching at a big church on the north side of town, and they all wanted to know. We preached at that church for 40 years, and many of them asked, "How's your wife? How's your wife? How's she going?" Because some of you know, my wife had a loss of leg movement, and she's had dementia as well. And we've found some very useful things to help in this. And as I mentioned this, quite a lot of the people said, could we have your notes as to what you've done? Because we've been compiling notes for the last 7 or so years. And we circulated it around. And one professor said, you need to share this around with as many people as you can. So we are making this available as of next week sometime. It should be ready. If you'd like part 1 of the dementia studies, then you can write to info@creationresearch.net. So if you put that up, please, Sam, and just ask Dementia Studies Part 1, info@creationresearch.net. It's turning out to be a real blessing with some things we've learned which are really helpful, other things that are not so helpful. And again, a forewarning to you, in case you get too excited about this, I have done a lot of study, and neither Diane or I or anybody else has found a single case of dementia that's been healed either naturally or supernaturally to date. But I suspect we are going to see changes in that. So again, lots of encouraging things, and I'd encourage you to contact us if you are worried about this issue of dementia in older age, or even in young people it's occurring. Write for the Dementia Study, Part 1, to info@creationresearch.net.
Great stuff. Thanks for that, John. And yeah, it's amazing some of the insight that the Lord has given John in particular. And it's great to have some confirmation that we're on the right track from a number of doctors and researchers. But I think the whole thing is just a reminder that we are on this good to bear to worst Bible. But the good news, of course, is that it's good to bear to worst to glory for those who actually trust in Christ. So we have that promise that is found in Jesus Christ's sacrifice and resurrection. We've got really only 3 minutes for questions, so Sam, perhaps we'll just have maybe one. So choose wisely, unless they're very short answers. But let's have any thank yous that have come through, if there are any, and a quick question.
No pressure, Joe. All right. We could do a quick fire round if you want.
Mhm.
We could do quick
Go
fire
for it.
answers.
Go for it.
Douglas asked this question: can you identify the kind of tree that made the amber?
You can essentially, the kind of is often pine. You're often able to get down to pine. Sometimes things like kauri, which I think kauri is a type of pine or conifer anyway, but you'll find most of them are pine, which is consistent with what we see today, with the majority of trees that seep large amounts of resin being pine trees or varieties of conifers anyway.
Well, just ask the sellers of Copel which tree they got it from, because it's fake amber. They make it on the spot.
Plus, one of the ways that you can tell whether it's amber or a stone, if you heat up a needle, okay, until it's piping hot, like, under a flame or a match, if you stick the needle into the amber, because it is an organic thing, it will burn, and you can smell pine, right? Like pine disinfectant or something. So that's another way of actually telling amber.
This is another one from Douglas. Even if you could get the perfect DNA sequence, would it be possible to form a dinosaur?
Diane?
No. DNA does not translate itself. It doesn't even reproduce itself. You need hundreds of other molecules in order to extract the information from DNA and turn it into actually living substance. DNA is simply a storage form of genetic information.
So you need a living creature that you could insert the DNA into, basically.
Yeah.
You need the hardware. And even if you do genetic modification where you take a fish gene and you insert it into a corn, it's still corn at the end of the day. It's a modified corn. It may be a slightly mutant corn, but it's still corn. You need that hardware in order to be able to have it to function. So the big moral debate at the moment is bringing back the woolly mammoths. Now, it's theoretically possible, certainly more plausible than dinosaurs, because we have a hardware, which is the African elephant, right, in which to actually utilize and basically clone a mammoth from the mammoth DNA that we get. But we don't have any such thing to do anything like that with dinosaurs.
Yeah. But you can have fish-flavored corn chips.
I did see the question about the time, Sam. Unique asked, what method of dating? I know on the Burmese amber, they're not given an age of the amber. That's the volcanic ash. And the volcanic ash is very questionable as to its source. And of course, it's questionable how it even represents time. Because when we test volcanoes that we know when they erupted, and we know they erupted 100 years ago, they give ages of millions of years. The whole testing technique is pretty bogus.
In fact, Joe, don't we have a program on dating? This is not dating to kiss like Craig was talking about, but dating the rocks. So you could reference.
This might be about dating amber, is it? This might be about dating the amber, is it?
It is. It's just generic in dating. So
yes.
We have a whole program on dating that you can look up on our sites.
And speaking of dating, Craig, I have to disagree with you about the, kissing, to remove microorganisms, but it is perfectly acceptable for us to pick ticks off of our mate.
Okay.
I just want to make sure you understand.
I just want a photo of you doing it with your mouth.
In America, we even write country music songs about, taking the ticks off of our mate.
Okay. Well, you are Americans.
All right. Well, on that note, we should probably bring it to a close. Thank you for joining us this week. It's been a fairly unique week of going down. And of course, you can always suggest topics that we may or may not take on, but it's been great to be able to deal with a topic that's been specifically requested. We will be back next week. I will be on the road somewhere, so we need to work out exactly what we're doing in terms of who's going to be there, but we will be back next week. Goodbye and God bless, and we will see you all very soon.
Goodbye.
Good night.